So this next section, which is about our process specification sheet, this is done so differently at every company. And usually the things that you see here are rarely all in one place. They're all over the place. They're held in different systems even, and different people are in charge of them. But I've decided to bring them sort of into one place, more like what we did at the company I worked for called Wemco, which was a really, really finely tuned, well run company where you could find everything. And although it didn't look like this, it was similar in that each job had a process spec sheet that basically told us where to go to find everything. And this was at the front of the folder for each special job that we did. And it allowed the engineers and marketing and purchasing and manufacturing all go to one place to get their information. And then if somebody needed to change something or fix something that was wrong, they could easily see what all was affected. So you will rarely, if ever, find anything that looks exactly like this. But we're going to talk about what each of these sections is for. And there are more things, more process specs that are required to make something. We're going to get into them in the next couple of weeks, but this will get us a start. So we're calling this a process spec sheet. It's a spreadsheet, and you have to say what it's for. That's what this top area is for. What is this for? And so there's usually something that lets somebody know, okay, you want the piston pump 1/2 inch or 0.45 cubic inch or whatever you're calling this thing. Go look it up here so you can search for that. Some sort of a description so that somebody goes, I don't get what that means. What is this thing? And this is our 1/2 by 1/4 inch piston pump assembly with a pneumatic drive. And what is this application? This is its final assembly. This is the top end. This is the end of the road. This is for everything. Okay. So this is what's called a bill of materials, and it's called single level because it doesn't tell us what each thing is made out of. So this is a single level bill of materials right here that you're looking at. And it could be that somebody would go, yeah, but I also want to know, I have to make this. I want all in one place, something that says what I make this out of. So some people insert a row right here. And they say, oh, yeah, and you make this from something, PLA in some certain amount. Okay, so, but we're going to use what's called a single level bill of materials. It's just the parts that go into that final assembly. And so if you want to know what it really takes to make this, we're going to need a multi-level bill of materials, which will be in one of the coming weeks. Okay, and so this is one of the things that I learned at Wemco is we've got this bill of materials, but there are processes that go along with it that production control wants to know about. And so if you put them right next to each other, it's just a little easier, and it avoids confusion when a person is looking at it. Now, computers cross-reference things, and it doesn't really matter. But if you're going to have somebody pick this up and try to make sense of it themselves, they're going to want to see it. So the process is either made or purchased, manufactured, purchased. Okay? And so we would want to know when you look at this saying, hey, is this something we made or do we just go out and buy a bunch of them? And different people in production control will look at just the things that they need to see and they want to look at. So you can imagine a purchasing agent would look at all the ones with P on it, and they would make sure that they've got all their purchased parts ready if somebody needed to build one of these. Okay? Or the inventory control manager would know, oh, I have I have to actually make these and I have to buy these, and the inventory control manager would start asking people to start working on it. So then the spec or the drawing that goes with it is pretty obvious, right? There's going to be some drawing. Often that drawing will have a bunch of different sheets on it. Okay, it might have the inspection sheet, the detail sheet, the casting sheet, the notes sheet, all sorts of stuff. So the drawing or the spec is usually a reference to where do you go to figure out how to make it. Okay, and so if I make it, somebody gets something called a work order that tells them step by step what to do to make it. And so there's usually for things like this some sort of a template that's not fully filled out. We don't know if I'm going to make 1 or 10 or 100 or 1,000, or which work center I'm going to do, or how many hours I'm going to assign to it. But there's usually a template that's pretty much pre-made that would say, okay, you're going to make some of these. Let me make my work order right now so we can keep track of it. And we know how many we're trying to produce at any one time. And then production control can start saying, you know, I've got 40 work orders for this one machine and 2 for another. Maybe I can trade some things around and move them around. It gets pretty cool and pretty complex. So a work order, W-O, a work order is generated for products that you're going to make. And of course, in a PO, a purchase order would be for what's going to get purchased. And these are just templates that make it real easy to pull a drawing, pull a piece of paper, hand it to somebody on the shop floor and say, okay, go make these. Right? So these are production control. How are we going to manage our production department and make sure we have enough people, enough materials, enough machines, and we have things being done in the right order? Okay, so production control always starts with some sort of process description. Is it a make? Is it a purchase? This can get more complex in these simple ones. There's usually some sort of a spec or a drawing that helps us understand this process. And then there's something that tells somebody to work or to purchase that part. Okay, so we have bills of materials, how many and of what they are, what to do with each one. And then this is really typical right here of this what to do with this thing. I'm going to make this thing. So this is sort of my top level work order. It's my assembly and test description of how to make this thing. Right? And so somebody would go, okay, if I'm going to make some of these things, what's it going to take? I'm going to go get some parts out of stores. I'm going to walk over to a shelf and get 1 of these and 2 of these and 1 of each of these. If I'm going to make 1, if I'm going to make 10, I'll get 10 of these, 20 of these, 10 of each of these, right? So it depends on how many I make. But for each one I'm going to do, I'm going to walk over to my storage cabinet or my shelves, and it's called pull parts or pick parts. And usually there's a time assigned to doing this. Okay, and sometimes that's a time for each one of these, and sometimes this time is for a whole batch. Okay, we're not going to get into that detail, but there's a time involved. And 0.08 hours. That's, I think, 5 minutes. So they're saying, okay, you got 5 minutes to go get those parts. So somebody better have them well labeled. Okay, then the next thing you do is you put together the threaded fittings. And there's some notes. It says use thread tape 3 wraps and then torque it. Ooh, so that's still not figured out yet, but torque is how hard you twist something together. Okay, it's sort of like how hard you push, but it's how hard you twist. And inch pounds means that if I had a lever arm 1 inch long, I would push on it or twist on it with 1 pound force at 1 inch. Twist. Okay, so if you look at it this way, if this thing was 1 inch long, I'd push on it with 1 pound and it would twist about my pivot point. That's what torque is. Okay. So this is giving some notes. There's some notes here that tell somebody when you assemble these things, put 3 wraps of thread tape and then torque it down to a certain amount. And somebody has figured out that that's going to seal up perfectly. Okay. And then it says once you've got all those thread things in place, put that piston, the spring, and the O-ring in. Okay, and use silicone lube on the O-ring. And this has an asterisk, and it shouldn't. Usually that signifies that there's some other note, and I don't have a note, so we can get rid of that. Okay, because somehow these O-rings don't want to run dry. And so the engineer has specified, or the designer, just dab a little silicone around that O-ring, assemble it, and put it in. And so now you're assembled, but it says to test it. Make sure that everything's working. And so you're going to test the piston's range of motion. You should be able to push it all the way in and all the way out. And usually there's a spec written for this. And you're going to push and pull by 10 pounds. And if you remember in the last week's work, we kind of figured out that with a 30 psi load, you could get 15 pounds. So this is just making sure that things work. Is 10 pounds good enough to push this thing back and forth? And that's, you don't know how to do this yet because our fingers aren't calibrated to 10 pounds. All of this is telling me that we need some special equipment designed and built, but that's not the purpose of this class. So once we know that it works, we want to do a functional assembly test. There is nothing worse than getting something to your client and then they find out it doesn't work. They've maybe waited 3 days, a week, a month to get this, and all their plans are set to go out on the river and use it, and they get it and it doesn't work. You'll never get that client back, and you'll probably get tons of bad reviews. So it's so much less expensive to spend 5 or 10 minutes even doing a functional test. And I'm saying here that you want to do it with 40 psi. And that's to make sure that nothing explodes or leaks when you do more pressure than it takes to run it. So you're going to stick this thing in the water and do some sort of submerged functional test. And again, there needs to be some sort of spec or test that goes along with this that tells you how to do this. Okay, so there's more work. This is just the start. Okay, but these were done in the stores area. These are all done in assembly and test. And then we're saying in this case, this should be op number 60. Go over to the shipping department and somehow you have to clean, dry, and pack that thing. So it's been wet. You can't ship it full of water. How do you clean it, dry it, and repack it? And we would individually pack it, less any tubing, right? We've already talked that this thing needs some sort of tubing for the air pneumatic drive and some sort of tubing to get the water from the discharge of this thing up to the sampling port by the ROV controls. So that's what we've got. That's just a little assembly and test description that lets somebody know. Okay, it's a process spec sheet. This is the process, and you go and get this stuff. If you need to make or purchase the stuff, here's the information on how to do it, and here's what to do with it. And there's still some stuff missing. It's not complete, but it gives a pretty good idea. So there we go. That's the essence of a process specification sheet. Often these things are done visually in some sort of a visual with pictures that show each of these steps. That's often done. Often there's something called a representative sample. There's one of these that's all built for the person to look at who's building the new one to help them remember what a good one looks like. We'll get into all that in a week or two, but this is part of your final assembly drawing, and it comes from it, right? Remember, we exported our bill of materials, and we've got an exploded view and a drawing that will help us know how to put all this together so it all ties in. All right, so that's how to make this. Oh, and how do I make this? I just start a spreadsheet and start working with it. This information comes from the export of your drawing. And there's a video for that, how to export. And then you just have to set up your spreadsheet to look like this and just start typing it in and making it happen. All right, so there's your how to and what it's all about.